Assalamualaikum warahmatullahi wabarakatuh. My name is Nuri Wahida Amalin, metric number S70154. The topic that I would like to present is countries using 7G network technology today. Problem statement. Transition to remote work. The COVID-19 pandemic led to a shift from traditional office environments to remote work setups. Second, mixed results. Research shows mixed findings. Some studies report increased productivity, while others highlight challenges like communication breakdowns, isolation, and difficulty separating work from personal life. Third, study goal. This study aims to explore the relationship between employer productivity and working from home, identifying the key factors that influence productivity in remote work settings. Research methodology. Quantitative method. Survey. A Likert scale survey was developed to measure work-life balance, productivity, job satisfaction, challenge faced while working remotely, administration. The survey was distributed online through Google Forms. Qualitative method interview. In-depth face-to-face interview were conducted with 20 employers to discuss their experience with remote work and how it affects their productivity. Results. Some countries are nearing the theoretical limits of 7G or even 8G speeds. Norway, average speed of 52.6 Mbps. Netherlands and Hungary, among the fastest connections. South Korea, Japan, Hong Kong, and Sweden, speeds close to 22.2 Mbps. However, full 7G or 8G networks are still in early research and are unlikely to become reality before the late 2030s. Despite this, these advancements show a bright future for ultra-fast connectivity. Recommendation: speed on innovation and research. Encourage university, teach companies and research centers to explore cutting-edge technologies like edge computing, AI, and quantum communication for 7G development. Second, boost cybersecurity measures. Build strong cybersecurity infrastructures to protect data privacy and security as 7G brings increased data flow and connectivity. Third, promote international cooperation. Governments and business should work together to create global standards for 7G to ensure compatibility and worldwide connectivity. The next topic is what we know about 7G after 5 and 6G. The problem statement is the evolution of mobile technology from 5G to 6G and beyond, including 7G, presents both challenges and opportunities. This includes infrastructure needs building the network that can handle increased bandwidth, lower latency, and greater reliability. Social impact, addressing how this advancement affects society, including ethical and technological implications. Functionality, ensuring future technologies support various applications like computing, communication, healthcare, and security. Research methodology, literature review. This section will review the current state of 5G, 6G, and 7G technologies, identifying potential advancement and challenge. The review will include insight from telecom companies, industry reports, and academic papers. Case studies. Case studies from early 5G adopters and research projects on 6G and 7G will provide practical insight into real-world application and limitation of these technologies. Comparative analysis. A comparison of 5G, 6G, and 7G will be conducted focusing on speed, latency, frequency spectrum system, architecture, application across various sectors. Simulation modeling. Advanced network model will simulate the challenge and compare the performance of 6G and 7G in rural versus urban settings. Peak demand periods. Expert interview with telecom expert engineers and research will be conducted to understand operational challenge of transitioning from 5G to 6G and 7G. Results. The study concludes that 6G will offer ultra-low latency and speeds up to 1,000 times that of 5G. By applying higher frequencies and unprecedented data throughput, 7G will further extend these capabilities with a tremendous impact on industries such as autonomous system, healthcare and security. Recommendation: international cooperation. The development of 6G and 7G standards will require global collaboration between governments, telecom companies and researchers. Law and ethical guidelines. Strict rules are necessary to protect privacy and ensure ethics in technologies like mind reading, spying, and predictive analytics enabled by 6G and 7G. Infrastructure investment. Governments and the private sector must invest in infrastructure to ensure rural and underserved areas aren't left behind in adopting 6G and 7G. Sustainability first. The environmental impact of 6G and 7G networks must be prioritized, focus on low carbon footprints, energy efficient architectures, and eco-friendly production to reduce carbon emission. Education and workforce development. Comprehensive training programs are essential to develop a skilled workforce capable of managing the complexities of 6G and 7G technologies, including network design, AI integration, and cybersecurity.